Hello and welcome to another episode of the GCSE Maths Question of the Week with me, Mr. Barton, where every week I treat you to a beautiful question that has been written exclusively for my Diagnostic Questions website to help you prepare as best you can for the demands of this new GCSE Maths exam. Now, you are in for an absolute delight this week because this is brand new content to the GCSE Maths. And it'll be no surprise, therefore, that when I look at the data on this question on my Diagnostic Questions website, it's causing students a lot of problems. But hopefully, with the help of this video, we're going to get to the bottom of why. So this question is being provided by OCR, and it goes a little something like this. What is the gradient of the tangent to the circle at the point Q12? Right, we've got a couple of things we've got to get our heads around before we get going here. Firstly, what does gradient mean? Well, gradient is the slope. What's the slope? Biggest one, tangent. What the flipping heck is a tangent? Well, tangent is a straight line. And there's a couple of definitions. The one I like best, the one I think is most helpful, is it brushes against the circle. Some people like to say it touches it once. Some people say it touches it an infinite number of times. God almighty. I like to say it's a straight line that just brushes against the side of the circle. Okay, so I'm going to sketch one in a second. At the point 1, 2. Now, I'm going to be honest with you. I will be mad at you, and you'll be mad at yourselves, if you understand everything, but then in the exam, you plot the wrong flipping point. It happens all the time. So just take your time and make sure you're happy where this point is. 1, 2. 1 on the X, 2 on the Y. So it is that point there. So what we're looking for is we're looking for a straight line that brushes that circle at that point. Well, let me see if I can sketch you one of these lines. So it's something like, and if I mess this up, I'll be able to move it. Oh, not too bad. It's something, I mean, it's not exactly like that. It's something like that. It brushes against it. And probably if I just kind of move it in a little bit closer, that's a little bit better. So what is the gradient of that line? Now, before we do anything else, this is always my advice when you're dealing with gradients. Decide first whether your answer is going to be positive or negative and just make a note of it. Well, that green line there, it's sloping downwards from left to right. So that's going to tell me that my answer has to be negative. And I'm just going to put that in a little bubble so I don't forget that. If it was sloping upwards, it will be positive. Okay? Next thing, how the flipping heck do I work out the gradient of that line? Well, I could start trying to estimate it and drawing triangles, but I don't want to be doing that because I want to be precise. So I've got to know a little fact about the radius of a circle and where it meets the tangent to the circle. So let me get my little straight line drawer back. And let me draw in the radius of the circle. Now you can kind of guess what's going to happen here from my diagram. But a mathematical fact is that the radius of the circle forms a 90-degree line with the tangent to the circle at that point. Now how does that help us? Well, you've got to know one fact and one fact only. If you can work out the gradient of the radius, if you multiply it by the gradient of the tangent, you get an answer of -1. And that relationship is always true for the gradient of any two perpendicular lines like we've got here. Some people prefer to think of it as this. Flip it and change the sign. That's okay. So flip it and change the sign. Or some people like to say it's the negative reciprocal. I don't mind. Mathematically, when you get to A level, that's the best way of thinking about it. But this is okay. Bottom line is we need to work out the gradient of our radius. And then once we've got this, that's going to help us get this using any of these methods. Okay? A lot of flipping work to do here, right? So how are we going to get the gradient of this radius? Well, we're going to draw ourselves a little right angle triangle. And we're going to remind ourselves that to get the gradient of any line, and we looked at this in an earlier video, we do the change in y divided by the change in x. How much does the height change of this right angle triangle compared to the base? So well, the height goes from 0 to 2. So the height of this triangle is 2. And what's the base of this triangle? Well, from 0 to 1, it's gone across 1. So my change in y is going to be 2. my change in x is going to be 1, so my answer is going to be 2. And notice my radius is sloping upwards, so it's fine to end up with a positive answer. Okay, so I've got my gradient of my radius, and I know that my gradient of my radius times by something is going to equal -1. Now, hopefully, you can spot what that number's got to be. Maybe you divide both sides by 2. I think that's how I would do it. Or if you prefer to think of this, let's flip it and change the sign, or take the negative reciprocal. However you prefer to think of it, hopefully you're happy in saying that the answer to that must be -1/2. So the gradient of my tangent is a negative reciprocal of 2, so it's -1/2. Now, does that fit in with what I wrote up here? It has to be negative, so that's looking good. It's sloping downwards, -1/2. I'm going to go with that. So that is, oh geez, that is answer B, -1/2. Now, that's only half the fun, and I know we've had a lot of fun there, so that's taken flipping ages. But whilst the party's carrying on, let's go for it here. Where might -2 come from? Well, I reckon you might go for -2 if you work out the gradient of your radius as 2, and then you think, well, the tangent is just a negative of that. So you've got 2 as your gradient of your radius. I'll stick a minus in, -2, that sounds about right. It's not right, it's the negative reciprocal. What about 2? Well, 2 is your gradient of your radius. So I reckon they've got that if they've actually worked out the gradient of the radius, not the tangent. And 1/2? Well, half's unlucky. I reckon you've worked out your gradient of your radius and you've done the reciprocal. So you've worked out 2, so you've done the reciprocal, which is 1/2, but you've forgotten the sign. You've forgotten which way it's sloping. Okay. At this stage of the video, I normally give you a 5th option, or challenge you to think of another wrong answer students may come up with. Instead, I'm going to do something slightly different here. I'm going to set you a little challenge. What I'm going to say to you is there's another coordinate. There's not just 1, 2. There's another coordinate on here where the tangent has got a gradient of -1/2. I wonder if you can find that other coordinate. Mysterious. Anyway, if you want a little bit of help on this, my first piece of advice would be to try the quiz out. It's a really challenging quiz, some lovely questions on there. And then if you still need help, hop on Mr. Barton Maths. You'll get videos, worksheets, all that kind of stuff. And I'll see you for a fresh question of the week next week. Take care. Bye for now.